This is the first video for section 2.3 of Pre-Calc 11. It's the second half of the trig unit. So in this particular video, we're going to be learning about something called the sine law. The driving force behind this lesson and behind this whole half of the chapter is how do we do trig? So not exact value trig, just basic finding values, angles and lengths. But how do we do trigonometry with non-right triangles? So that's our big question. If you're watching this video, ideally you should have probably watched all of the stuff for the first half of the unit, so everything from 2.1 and 2.2. But the nice thing about this is that none of that is super essential for understanding this lesson. So if you haven't seen it yet, or if you're feeling a little bit rusty on it, you should still be fine here. I do recommend kind of getting those settled, but you are good to watch this if you're still not 100% sure on your special triangles or your ASTC or that kind of stuff. So let's see if we can answer this. So before we can get into it, just a quick refresher on something that we did back in the trig review. If we're working with a triangle, so whether it's a right triangle or a non-right triangle, let's say something like this. When you're labeling things, and so this is going to be super essential for this video, when you are labeling things, there's specific ways you are supposed to label your angles and your side lengths. So first, your angles need to be uppercase. So capital letters. So I'm going to go in this case with kind of the standard A, B, and C. Your sides are lowercase. So angle A, or sorry, side A, side B, and side C. And angles and sides that are opposite each other use the same letter. So you can see that in kind of what I've drawn here already. So we've got angle A across from side A, and so on and so on and so on. So angles and sides, sorry, angles and sides, not angles are sides. Angles and sides that are opposite use the same letter. All right, so with all that being said, we're now ready to get into the sine law. I'm not going to get into where the sine law comes from or prove it mathematically. If that's something you're interested in, there's lots of places online where you can look that up. You can also probably go see me if I'm your teacher, or whoever your teacher is, go see them, or come see me regardless if you're at Canby. But point being, I'm not going to get into the theory behind it. I'm just going to tell you what the law is. So here it is. The sine law is sine A over A equals sine B over B equals sine C over C. So all this is saying is that the sine ratio of an angle divided by its opposite side is going to be the same for all the angle and side pairs in a triangle. Typically, we're not actually going to work with 3 of these at once, so it would really probably just be those first 2 that you'll see. The specific letters don't matter. What does matter is that every fraction uses a paired angle and side. So A over A, B over B, C over C. We can use the sine law in 2 sorts of situations. So it's useful when you know either 2 sides and 1 opposing angle. So it has to be an opposing angle. When I say opposing, I mean it has to be across from one of the sides that you know. Or when you know 2 angles and any side. So you'll notice in both of those cases, you need to know at least 3 things, right? So 2 sides and an angle, or 2 angles and a side, but that's still 3 bits of information about your triangle. If you don't know at least 3 things, neither sine law nor cosine law is going to be useful for you. So let's try putting this to work. So we're going to figure out an angle first, so determine angle theta to the nearest degree. So let's sketch ourselves out a triangle. It's going to look something like this. angle A, angle B, angle C. This side's going to be 5, this side's going to be 7, this angle is going to be 40, and this angle is going to be theta. That's the one that we want to find. So if we write out our sine law, so sine of angle A over side A equals sine of angle B over side B, and I'm not going to bother writing the third fraction because, again, it's not actually usually helpful. I've used A and B here because, well, really just because they're the first two parts of the equation, but they are actually the ones we're really going to be looking at in this particular equation. So let's start by filling in what we know. So that's step 1. Just fill in any information you have. So in this case, we know that angle A is theta, so that's the thing that we're trying to find. So we don't know it, but we have something to represent it. We know side A, which is across from angle A, is 7. Then we know angle B is 40 degrees, and side B, which is across from that 40, is 5. And so notice that we have one opposite pair of angles and sides. And so you cannot use the sine law without at least one pair, because if you don't have that pair, then you're not going to be able to fill anything in, right? So if this 5 had been over here instead, we wouldn't have anything that we could have paired up, and none of our fractions would have been useful for us. So you've got to have that opposite pair. All right, so step 2. Now we want to isolate, basically we're trying to solve. So we want to isolate theta, but before we can isolate theta, we should probably isolate sine theta. And the way we're going to do that is we're just going to cross multiply. So sine law uses a lot of cross multiplication. So if we take sine theta over 7 equals sine 40 over 5, we can actually shortcut a little bit here. So yes, we do need to multiply the diagonal things to cross multiply, but we can also notice that since we've just got one thing to move, it's just the 7, we could get away with just multiplying both sides by 7. Both of these are totally valid. So if you cross multiply, you would get 5 times sine of theta equals 7 times sine of 40. You would divide both sides by 5, and you would get sine of theta equals 7 times sine of 40 divided by 5. If you had noticed that you could just multiply by 7 right from the get-go, that's just going to get you into that same spot. Right? So you're going to be moving the 7, and this would become 7 times sine of 40 over 5. So same thing, either way. So this thing does have a value. This 7 times sine of 40 divided by 5, it equals roughly to 0.9. We don't want to do that. So a big place where people go wrong with sine law and the cosine law that we're going to see after this is they start rounding too early. So you really don't want to round anything when you're doing this until the very end of the question. So there's different ways you can get around that. If you know how to use your calculator properly, you can just store numbers in your calculator. You can reuse previous numbers that you've calculated. You can use your answer key, whatever. So you really want to make sure you have a good sense of how your calculator works, because you don't want to be using 0.9. You can write down 0.9 if you really want to, but you're not going to use it in your calculator, because the more you round, the worse your answer is going to get. So if you don't know how to use your calculator in order to store things, do definitely make sure that you get that checked out with your teacher so you can figure out how to do so. All right, so to get theta now, we're going to use our inverse sine function, the same way that we would have done with basic, right angle trig. So that's your sine -1. And so that's just using your shift key on your calculator or your second button on your calculator or whatever it would happen to be. So what we've ended up with now is theta is sine -1. Again, you can write down 0.9. We're not going to use 0.9. So if you have a way to store that in your calculator, you can definitely use the decimal. Or what you can also do is theta equals sine -1. And then you can just type out that whole thing and have 7 sine 40 divided by 5. And if you can get that written into your calculator, that will work too. One way or another, we should end up with our angle is 64 degrees. And so that seems like a lot of work, but really the sine law is not that bad once you get going on it. So let's try another one, and we're going to go through this one a little bit faster. So we want to determine angle B on this particular triangle. So I'm going to tell you that this is 36. This is 23.4. This is 24.8. Well, let's make that 34.8 actually. Never trust my drawings to be to scale, by the way, if you're in my class or you're watching my videos. I can't draw, as you've probably noticed. And so we're going to go with this. So technically, if we were writing this out properly, looking at what we've got angle C, we've got side C, and we've got angle or side B, and we want angle B. So we're working with the B's and C's, not with the A's. So if you're writing this out, technically properly, you'd write sine B over B equals sine C over C. Again, the letters really don't matter. You could do A and B. I really wouldn't care as long as you're pairing things up properly. So angle B, we don't know. We're just going to leave it as sine B. Side B is 23.4. Angle C is 36. And side C is 34.8. So to solve for angle B, we can just multiply both sides by 23.4, or we can cross multiply. You'll get to the same spot either way. These are going to cancel. And so we're left with sine of B equals 23.4 sine of 36 over 34.8. And so that is what you want to be putting into your calculator. So again, you could do it right now, and you're going to get yourself an answer of 0.39, or even if we go a little bit further, 0.3952. And that's okay to write down, but again, we don't want to use that. We don't want to round. So we're going to do B is sine negative 1 of that 0.39 something. If you calculated this, your calculator probably has a button that looks like this. It might be a button, or it might be on your equals button. It might be sort of like the small text above the button. So if you use that, that will just reuse the last thing you calculated, which should probably have been this 0.39. So if you do that sine negative 1, you should get, for your angle, 23 degrees. All right, so I'm going to give you one of these to try for yourselves. And then we're going to try going the other way and doing some side lengths. All right, so here's a triangle. We've got 41, we've got 17, we've got 22, we got theta. I know this looks like a right triangle. You can never assume unless you're explicitly told. It's not. I just can't draw. So go ahead and try this one out for yourselves and see how it goes. All right, so if we set things up, sine of theta over its opposite side, so 22, so that's like sine A over A, equals sine 41 over 17, right? So again, those are opposites. We're going to multiply both sides by 22, and we're going to end up with sine of theta equals 22 sine 41 over 17. And if you do your sine negative 1 of that, what you're going to end up with as your angle is 58 degrees. Oops. So make sure you can get 58 degrees out of that. So now that we've figured out how to get angles, now it is time for us to figure out how to get lengths. So let's see if we can go another way. So I'm going to give you a triangle, and we want to see if we can get the length of side A. So we've got an angle of 50 degrees down here. That's angle A. We've got an angle of 60 degrees. That's angle B. That's going to be 10. And so there's everything we have. So it's still just sine law, right? So sine of A over A equals sine of B over B. We're still just going to plug everything in we know. So angle A we have is 50 degrees. Side A, we don't know. That's what we're trying to find, so I'm just going to leave that as A. Angle B is 60, and side B is 10. So it's still just write out the thing, plug in all the numbers. Now we really do need to cross multiply. So we're going to multiply our diagonal stuff. And so I'm going to get a times sine of 60 equals 10 times sine of 50. Well, to solve that for a, we need to get rid of the sine of 60. And so remember, this is just a number. Sine of 60 has a value. So we can move it just like any other number. So we're going to divide both sides by sine of 60. And so what we end up with is a equals 10 times sine of 50 divided by sine of 60. And so if we put that into a calculator and calculate it, we don't even have to do the inverse sine stuff now. We're just plugging it in. What we should end up with is 8.85. Remember, this is a side length, so we're going to go to 2 decimal places. And if you think about the question, that does make sense. So angle 60 is across from 10. Angle 50 is a slightly smaller angle, so it should be across from a slightly smaller side. So we should have gotten something slightly smaller than 10, and we did. All right, trying out another one. So go ahead and give this one a shot on your own. So you're going to figure out the length of x. And you should be able to handle this, right? So it's just plugging in numbers and calculating and seeing where you end up. So this angle is 75. This angle is 56. And we got 7, 9, and x. So go ahead, give this one a shot, and see what you end up with for your side length. Okay, so there is a bit of a trick on this one, a really small trick, that I've actually given you an extra number, an extra side length. So if we're looking at this, 75 is across from 9, and 56 is across from x. This 7 is actually totally useless for us. It's just a distraction. So if we plug everything in, we've got sine of 56 over its opposite side of x equals sine of 75 over its opposite side of 9. We do some cross multiplying. We end up with x times sine of 75 equals 9 times sine of 56. We divide both sides by that sine of 75 to isolate x. And so we get x is 9 times sine 56 divided by sine of 75. So that's what you want to put in your calculator, which is going to get you your final answer of 7.72. Okay, we're going to do one more. Before we do, just one quick note. There is a different way of writing the sine law, which is basically just the same thing, but just with one small but very obvious change. So you can also write the sine law as the following. A over sine A equals B over sine B equals C over sine C. So it's the same thing, it's just everything's been flipped. And so this is typically used more for calculating lengths. I personally basically never use it. I find it's easier just to stick with one law and just learn how to use that one law well. But you are welcome to use it yourself if you want to. And I'll kind of show you how it's done on this particular next question once it's my turn to do it. So let me get you a triangle. So we're going to determine x in this triangle. And this angle is going to be 110. This side is going to be 20. And this angle is going to be 41. And we want to find x, which is this side down here. So before you start this one on your own, you might notice, if you think about it, that there is a bit of a problem here. So at first glance, well, we've got 110 paired with 20. So that's great. We've got one opposite angle side pair we can work with. But what we don't have is the angle across from x. So if we're going to be doing sine law, we need to know this angle, right? Because you can't really work with just 110 and 20. And the 41 is not where we need it to be. But here's the thing. If we go way back to the start of the lesson, I did tell you that sine law was when you have two sides and an opposing angle, or two angles in any side. So looking at this particular one here, even though we don't necessarily have the angle we need, what we can do is remember a very important fact that all the angles in a triangle always add up to 180 degrees. And so since we know two of the angles already, if we just do 180 minus the two angles that we know, 110 and 41, then we'll be fine. So 180 minus 110 minus 41 gets me 29 degrees. And so that is this angle up here. This is 29. And now you should be ready to actually go through and figure out your missing side. So go ahead, pause here, try it out if you can, and then come back once you're done. So if I'm using that flipped version of the sine law, so we're going to have x over its opposite angle, so sine of 29 equals 20 over its opposite angle, sine 110. And so now we don't have to actually cross multiply. All we need to do is move this sine of 29. So all I need to do is multiply by sine of 29 on both sides. And I end up with x equals 20 times sine 29 divided by sine 110. So I don't find that it's worth the effort of remembering a different formula just to kind of skip the extra step in cross multiplication. If you want to, you're more than welcome to, but I would probably have just used the flipped version, or like the original unflipped version of the formula, personally. Either way, if you plug this in, what you're going to end up with as your final answer is 10.32. And then we do have units, so it's 10.32 feet. And so there we go. There is your sort of intro to the sine law. It's pretty easy to use, but unfortunately, you might have noticed that there's 2 more videos for the sine law because it's about to get a whole lot more complicated. So once you feel like you've got a handle on sort of these basic ones, go ahead and move to the 2.32 and 2.33 videos where you'll learn that the sine law is way harder than it seems. So good luck with that once you get there.